I am Precious Hecille TEJERO, your precious educator. And today we're going to explore a topic that connects chemistry, biology, and real-life nutrition, lactose. Most of us consume milk or dairy products regularly. But have you ever wondered what's really in them and how our bodies process them? Most importantly, have you heard of people who get stomach pain or bloating after drinking milk? That's what today's lesson is all about. So for today's learning objectives, we have to identify the chemical structure, linkage, and components of lactose, explain the functions of enzyme lactase in lactose digestion, and lastly, describe the cause, symptoms, and diagnostic methods of lactose intolerance. So before we dive into our main topic, which is the lactose, let's take a quick review of what we already know. Monosaccharides is the simplest carbohydrates and serve as the building blocks for more complex sugars. When two monosaccharides combine through a glycosidic bond, we get a disaccharide.
Now, here's a quick question for you. Can you name 3 common disaccharides we encounter in food or the human body? Think about it. Yes, we have sucrose, which is glucose plus fructose, maltose, which is glucose plus glucose, and lactose, made of glucose and galactose. So, which one of these is naturally found in mammalian milk? That's right, lactose. It's an important energy source, especially for infants. With that in mind, let's move on and explore the structure, components, and the fascinating topic of lactose intolerance. I'll be introducing a key carbohydrate found in many of our everyday foods, lactose. Lactose is a type of disaccharide sugar, meaning it's made up of 2 smaller sugar molecules, glucose and galactose. These 2 units are linked by a B1,4 glycosidic bond. Lactose is naturally found in the milk of mammals, which is why it's commonly referred to as milk sugar. You can find lactose in a wide range of dairy products, such as milk, cow, goat, or even human breast milk. Next is cheese, especially softer types like cream cheese or cottage cheese. And lastly, yogurt, ice cream, butter, and even in some processed foods that contain milk ingredients. Lactose plays an essential role, especially in infant nutrition, as it's the primary carbohydrate found in breast milk. It provides a quick and accessible source of energy, which is critical for a growing body and brain. In addition to being a fuel source, lactose also aids in the absorption of calcium and magnesium, minerals that are crucial for developing strong bones and teeth. It also supports the growth of beneficial gut bacteria, which help maintain a healthy digestive system. For adults, while the role of lactose becomes less prominent, it still contributes to overall energy intake and digestive health, as long as the body continues to produce lactase, the enzyme needed to break it down. In summary, lactose is much more than just milk sugar. It's a valuable nutrient that supports energy production, mineral absorption, and gut health. Understanding lactose helps us appreciate the importance of dairy in the diet and also prepares us to explore related topics like lactose intolerance and digestion. Now that we've introduced lactose, let's take a closer look at its structure. As we remember, lactose is a disaccharide, which means it's made up of 2 simple sugars, galactose and glucose. These two are joined together by a beta-1,4 glycosidic bond, which is a type of covalent bond that connects sugars. This bond links the first carbon of galactose to the fourth carbon of glucose. And it's called beta because galactose is in its beta form. In simple terms, this bond forms when a water molecule is removed and the sugars are connected through an oxygen bridge. The systematic name of lactose is beta-D-galactopyranosyl 1,4-D-glucose. You'll mostly find this sugar in milk and dairy products, where it serves as an energy source. Now, for the chemical formula, lactose has the formula C12H22O11. This tells us it contains 12 carbon atoms, 22 hydrogen atoms, and 11 oxygen atoms. So, to sum it up, lactose is made of galactose and glucose, linked by a beta-1,4 glycosidic bond, and has the chemical formula C12H22O11. Understanding this structure helps explain why some people can't digest it properly, especially if they lack the enzyme lactase, which breaks this bond during digestion. Lactose digestion begins in the small intestine, where the enzyme lactase plays a crucial role. Lactose, a disaccharide composed of glucose and galactose, is too large to be absorbed directly into the bloodstream. To be utilized by the body, it must first be broken down through a chemical process called hydrolysis. The enzyme lactase recognizes lactose and binds to it in a lock and key manner, catalyzing the hydrolysis reaction by adding a molecule of water to break the bond between the two sugars. This results in the formation of free glucose and galactose molecules, which are then absorbed through the intestinal lining and used by the body for energy.
Stop! Let's check your understanding. After learning all the new information, let us try answering these questions. You may pause the video to think about your answer. What are the two monosaccharides that make up lactose? That's right, glucose and galactose. Next, what is the name of the enzyme that breaks down lactose? Right, the enzyme that breaks down lactose is called lactase. Lastly, what role does the lactase enzyme have? The lactase enzyme breaks down lactose into glucose and galactose so they can be absorbed by the small intestine.
While dairy products are a major part of many diets, not everyone can digest them comfortably. But why does this happen? The answer lies in a tiny but essential enzyme called lactase. Without sufficient lactase, this process is impaired, leading to lactose intolerance, a condition where undigested lactose remains in the gut and causes symptoms like bloating, gas, and discomfort. When lactose is not digested in the small intestine, it moves into the large intestine, where it is broken down by gut bacteria. This process produces gases like hydrogen, methane, and carbon dioxide, leading to symptoms such as bloating, gas, cramps, and diarrhea. Lactose intolerance is often genetic. Babies produce a large amount of lactose to digest breast milk. However, as some children grow older, their lactase production decreases, a condition known as primary lactase deficiency. In other cases, conditions like celiac disease or Crohn's disease can damage the intestines and lead to secondary lactase deficiency. Doctors use several tests to diagnose lactose intolerance. The hydrogen breath test is one of the most common. After drinking a lactose solution, hydrogen levels in the breath are measured. High levels suggest that lactose was not properly digested. Another method is the lactose tolerance test, where blood sugar levels are checked before and after consuming lactose. If the sugar level does not rise, it means the lactose wasn't broken down. Finally, there's the elimination diet, where dairy products are removed from the diet for a few weeks and then reintroduced to check for symptoms. While lactose intolerance cannot be cured, it can be managed. Many people can tolerate small amounts of lactose, especially when consumed with other foods. Others may prefer lactose-free dairy products or take lactase supplements to aid digestion. To sum up, lactose intolerance is a manageable condition caused by a deficiency of the lactase enzyme. It affects how our bodies process dairy, but with proper awareness, testing, and diet adjustments, people can continue to live comfortably and healthily.
Read the scenario carefully. Remember and apply what you have learned today and conclude your answers. Imagine you are a future medtech. A child experiences stomach pain and bloating after drinking milk. What condition would you suspect and what test might be done to confirm it? Answer is lactose intolerance and hydrogen breath test or lactose tolerance test.
We have here some key takeaways. First is lactose is a disaccharide made up of glucose and galactose connected by a B1,4 glycosidic bond. It is commonly found in mammalian milk and dairy products. Next, lactase is the enzyme produced in the small intestine that breaks down lactose during digestion through a hydrolysis reaction, allowing glucose and galactose to be absorbed in the bloodstream. Next, we have lactose intolerance occurs when the body does not produce enough lactase, resulting in undigested lactose reaching the large intestine, where it is fermented by bacteria, causing gas, bloating, and diarrhea. And lastly, diagnosis methods include the hydrogen breath test, lactose tolerance test, and elimination diet, which help determine how the body responds to lactose intake.
That sums up everything about lactose and lactose intolerance. Thank you for listening. Until I see you next time. Ciao!